Hello viewer. In this video we will discuss all about computer data structure, which will certainly enhance your knowledge and be helpful in any examination. Please subscribe to motivate for more such contents. A data structure is a way of organizing and storing data to perform operations efficiently. It defines the relationship between the data elements and the operations that can be performed on them. The choice of a particular data structure depends on the nature of the data, the operations to be performed, and the efficiency requirements. Here are some key concepts related to data structures. Data element. A data element is the smallest unit of information in a data structure. It could be a simple data type, like int, float, char, or a complex data type, like a structure or class. Data structure. A data structure is a way of organizing and storing data such that it can be used efficiently. It involves defining the relationships between data elements and the operations that can be performed on them. Types of data structures. Primitive data structures. These are the basic data structures that directly operate upon the machine instructions. Examples: int, float, char, etc. Non-primitive data structures. These are more advanced data structures that are derived from primitive data structures. Examples: arrays, linked lists, stacks, queues, trees, graphs, etc. Arrays. An array is a collection of elements, each identified by an index or a key. Elements in an array are stored in contiguous memory locations, which allows for efficient random access. Linked lists. A linked list is a collection of nodes where each node contains data and a reference, link, to the next node in the sequence. Linked lists can be singly linked, each node points to the next, or doubly linked, each node points to both the next and the previous. Stacks. A stack is a last in, first out, LIFO, data structure. The last element added is the first one to be removed. Common operations include push, add an element, and pop, remove the top element. Queues. A queue is a first in, first out, FIFO, data structure. The first element added is the first one to be removed. Common operations include enqueue, add an element, and dequeue, remove the front element. Trees. A tree is a hierarchical data structure composed of nodes. Each node has a value and 0 or more child nodes. Common types of trees include binary trees, AVL trees, and B trees. Graphs. A graph is a collection of nodes and edges, where each edge connects to nodes. Graphs can be directed, edges have a specific direction, or undirected. Hash tables. A hash table is a data structure that uses a hash function to map keys to indexes, allowing for efficient data retrieval. It is commonly used for implementing associative arrays, sets, and caches. Complexity analysis. Analyzing the time and space complexity of algorithms that operate on data structures is crucial for understanding their efficiency. Choosing the right data structure for a specific task is essential to ensure that operations are performed efficiently. Different data structures have different strengths and weaknesses, and the choice often depends on the specific requirements of the problem at hand. Thanks for watching. Please subscribe to motivate for more such contents.